Welcome back to Lesson 2 on Probability. We're now ready to move on to page 2, and before we do that, let's just take a quick review of where we've been. On page 1, we were looking first at a contingency table of customers of an insurance company, and we computed a number of probabilities, first of all by looking at this table itself, and we said that's called a contingency table, and we explained how you can represent the same information with another kind of diagram called a Venn diagram. We won't go through that again, but just that's where we are in the lesson. If you're needing some of that material, go back and look at the one of the 3 parts on page 1. At this point, we're now ready to move on to page 2, which begins with another example. And it says we're supposed to roll a die, list the possible outcomes. Those are, of course, 1 through 6. Let A be the event that the number is prime. Let B be the event that the number is odd. We want to compute the probability that either A or B occurs, and do this by both direct counting and by the addition rule. This is really just practice for what we did before, so we'll move along fairly quickly. We remember on the first page we learned this addition rule. The probability of A or B is the probability of A plus the probability of B minus the probability that both A and B occur together. In our particular case, the sample space are the number of dots showing on the die, 1 through 6. These are equally likely, so of those 6 outcomes, each has a probability of 1/6. We're interested in the 2 events odd, which would be either 1, 3, or 5 dots showing, and a prime number of dots showing, 2, 3, and 5. Using our addition rule, we can compute this probability. The probability of rolling a number that is either odd or prime, or perhaps both, is the probability of odd plus the probability of prime minus the probability of both odd and prime. Probability of odd, well, there are 3 outcomes of the 6 that are odd, plus the probability of prime. Likewise, there are 3 outcomes that are prime, minus the probability of getting a number that's both odd and prime. Well, we notice that the overlap between these 2 events is the 3 and a 5, so there are 2 out of the 6 ways of rolling the die that will give a number that's both odd and prime. Computing the sum now, we see that we get 4 out of 6, or 2/3, is the probability of rolling a number that's either odd or prime. Now, the instructions said to do this both with the addition rule and just by direct counting. By direct counting, you would do something like this. What are the numbers that are either odd or prime? Well, odds, 1, 3, and 5. And have we missed anything with primes? Well, yes, 2 is prime. And of course, 3 and 5 are also prime, but we don't need to check those. They've already been checked off once, so that we see that there are 1, 2, 3, 4 of the 6 outcomes that are either odd or prime. 4, 6 reduces to 2/3, and that gives us the same result as if we used the formula. Now, that raises the question, if we can always do these probabilities without the formula, why do we bother with the formula? The answer is that you can't always do without the formula. Sometimes we're simply given this kind of information ahead of time. The probability of event A is 1/2, the probability of event B is 1/2, the probability that A and B occur together is 1/3. What's the probability that A or B occurs? And you'd have exactly this calculation here, but you wouldn't be able to go back and do a count because we are not given that kind of information. So this formula is indeed useful, and we will make use of it as we make our way into the homework problems. So let's take an example where we really need the formula. Let's suppose a neighborhood clinic that's operating in a low-income neighborhood looks over their records and determines that 28% of the patients they see are diabetic, 12% of the patients have asthma, and 4% of the patients have both diabetes and asthma. What proportion of patients have at least one of these conditions? Well, let's see two ways to solve that. One way would be with the addition formula. The probability that a patient selected at random has either diabetes or asthma is the probability that a patient selected at random has diabetes, plus the probability that they have asthma, minus the probability that they have both of these conditions. Probability of diabetes is 0.28 or 28%. Probability of asthma is 0.24. Subtract off the probability that these two conditions occur together, which is 4%. Add these up, and we come up with 0.36 or 36% of patients have one of these two conditions. Well, I said there were two ways to solve this. What else could we do besides using the addition formula? Well, it turns out a Venn diagram would work very nicely. So we've got one started here with two circles, so we're going to be looking at two classes. It'd be natural to say that one of these classes stands for those patients who have asthma. All the patients who have asthma will be somewhere in this circle. There are those patients who have diabetes. They will be somewhere in this circle, and right here is the region for patients who have both asthma and diabetes. Well, we have right here from our data, there are 4%, let's work with percentages on these, there are 4% of patients who fall into that category. Now, what about patients who have asthma? 12% of our patients have asthma. 4 of them are here, so 12 minus 4, 8% must be in this region. Notice we have preserved the total correctly. 8 plus 4 is 12. 12% of patients fall within the asthma circle. Well, what about diabetes? 28% of patients fall within the diabetes circle, but 4% of them are here. The remaining 24% are out here. This tells me now that the probability that a patient has either asthma or diabetes would simply be the sum of these numbers. 8 and 4 make 12, 12 and 24, 36% have one or both of these conditions. Now, something else pops up for us when we look at this diagram, and that is we notice that the outside of the circles has not been labeled yet. We have accounted for those patients who have asthma, those patients who have diabetes, and of course those patients who have both. What proportion of patients have neither diabetes nor asthma? Well, diabetes or asthma is just everything in one of the two circles. We have a total of 36% of our patients fall there. So 64% of our patients have neither asthma nor diabetes. And that's something that's quite easy to pick out by looking at the Venn diagram. Maybe not quite so readily discoverable if we're using the sum formula.